Okay, let's get started. We're going to work with this part right now. It's set up right now. It's just got the top plane. It's oriented with the origin bottom center of the shift knob here. That will be our original 5-axis origin. So that is going to be our WCS all the way through. All right. So let's go ahead and go to our planes. And just so it has a designated name, let's make a copy of the top plane. So I'm going to right click and duplicate it. And then the duplicate we can rename 5-axis WCS. And then make that your active plane. Okay, it's just a copy of the top plane, but I'm just going to name it that way I recognize that needs to be my WCS, because when I set the machine up, I'm going to indicate that trunnion flat. I'm going to, whatever my fixture is, I'm going to get the rotary table indicated in square. Okay, and then I'll set my X, Y, and Z from there. So I'm going to have my X, Y, Z, A, and C all set at the machine. Okay. All right. So first things here, what I would do is I would get, typically when I program on the 5-axis, I batch program. So everything I'm going to do with whatever tool it is, I try to do that first. Even if it's different orientations, I don't want it changing tools for every different orientation. So like everything we're going to do with the 1/2 inch here, which we're going to bore out these holes. We're just going to do a circular bore on all of them. And we're going to do a little spot face here on the top of it. We're going to do all of that with the 1/2 inch end mill. These particular shift knobs, what we would do with these when we were making them in industry, we would have them turned off of the lathe. So they would come from the lathe, they would get faced, they would get tapped with a 3/8/16 threaded hole, and then we would turn the entire profile, and then there would always be, just like what you've seen on your parts that you've been making, you know, there'd be a little nub here where the part off would be, and we had a bucket we'd stick in the machine and they'd drop into with a piece of foam in it, and they'd just sit there and run them. We had a bar puller that would pull them out, and it'd run a 4-foot bar at a time. I think it made like 20 to 25 pieces per run, and then you'd load up another bar, hit go, and it'd just sit there and run out the blanks. They're 1 15/16 inch diameter. So if you go in your levels here, you'll see I've got a stock model set up, which kind of represents that complete round part. It doesn't represent the nub on the end where the part off is, but I'm not too worried about that. Okay, so back to my isometric view. So let's start off with our toolpaths. Let's make sure we're in our toolpath manager. Everything looks good here. The tools are already loaded in to the file, so you won't have to do any of that. The tool settings, it's got assign tools sequentially, warn of duplicates, and once you use the tools, step, peck, and coolant, let's turn that on. Surprised it wasn't already on. Notice up here, see that weird number? When I was in industry, okay, the machine I ran, it didn't link the programs to the file name. Everything was linked to the program number. So we had literally a series of numbers that we would use, and that was whenever we made this was program 16,754. And whatever I wrote after this, that became 16,755. Okay, and we kind of matched those up to the different companies because we had 3 different companies that we did work for, so that we could keep track of the files. So that's why it's got that weird number you see up there. Stock setup. For that, let's go in and tell it we're going to pick a solid for the stock. And let's go here to select it. You have to turn that solid level back on so that we can pick that sphere that's there. So I just went into levels, turned on the stock model level, and picked that round ball. And you notice it brought in the 1 15/16 inch for all the sizes. And then I can check mark. And I'm going to shut that one back off. Everybody good? Check mark. basically what we're going to do here is we're going to use the same toolpath several times, and we're going to do what is the easiest option for us because we've got repeating features around the part. If we didn't have repetitive features, we'd have to set up planes, you know, multiple times here for each different side to go to that side to do different type of work. But since it's the same hole all the way around the part and at those angles, we're going to be able to use the transform rotate to create those. We'll actually set 2 planes up and then transform rotate to do the other 3 locations. So we're going to do 2 planes. Won't be too bad. For the first one though, we don't need a new plane. We're just working in this 5-axis plane. Let's go ahead up here and pick the contour. And you can leave the NC name just like it is. And for the edge that we want, I just want this bottom edge of this top face here. So I'm going to pick that right off the solid. And I'm going to make sure the arrow is going which direction since we're doing a contour. Counterclockwise. We want to cut on the inside, so we want to make sure that arrow is going counterclockwise. Go ahead and check mark. For the tool, I'm going to pick my 1/2-inch flat end mill here. So a little fun fact there, I didn't pull the one out of the VU library. This one was in the program already. See how the feed and speed's really slow compared to what we're used to running? The mill that we used to run these on only had a 5,000 RPM spindle. So that's why the RPM for this tool is set so low. We don't need to worry about that today, but I would probably speed that up if I could because I've got a 15K spindle on the 5-axis out here. All right, we're going to call this the spot face. Top of knob. Cut parameters. We're not going to worry about using cutter comp for this. We're just kind of going through the motions here. We're going to do a contour type ramp. And then I'm just going to set this to a depth to where it ramps 20 thou every pass. And I want to make sure it makes a pass at the final depth. That way it cleans up the entire floor in there. For the lead in, lead out, this is a pretty small area that we're working in. If I go look at this bore, this thing is 750. So obviously I can't have 100% lead in, lead out. Let's just set those both at 10% on the line and the arc. And then let's add in our 5% overlap on for the wall. So 25 thou. After that, we could turn on multi-pass if we wanted it. Okay, I'm not going to worry about it today, but if I wanted a nice, real good finish, I'd probably turn on multi-pass to clean the wall up. In the original file, it probably has that on because I wanted these to look really nice right off the machine and not need any finish work. Let's go to our linking parameters. And here we got to think of just a little bit. Now it's pulling in the top of the stock from the stock model. Okay, which is good for us. Notice it's a kind of an oddball number, and basically that's because that flat that's milled on the bottom of it and then that thing's centered up on it, it's pulling literally where it's at there. I would probably go ahead and set that at like 1.8, even though it's a couple thou taller, just so I'd have a nice whole number to work with there. After that, my depth, I'm going to set that to an absolute value, and I'm going to pick the bottom edge here. Now, if we would have left it at incremental 0, would it have worked? Yes, it would have, because it's going incremental from the chain that we picked, as long as you pick the chain at the bottom of that spot face. The rest of these, I'm just going to leave them as they are. I am going to turn on the clearance and set that to incremental 2 inches above. 5-axis, typically my feed plane, my retract, and my clearance, I always work in incrementals. Okay, I always want those going incremental from wherever I set that top of stock value at. Now, in our planes, we'll go ahead and take a look at them. They should all read 5-axis WCS. Here's something we need to make sure we do here. We're going to set the work offset to 0 here. And you don't want to leave that, if you know you're going to use a transform plane like I talked about, you do not want to leave that on automatic, because what it will try to do is, when it transforms, it will try to go and create new work offsets each time it transforms. So it'll try to do a G55, G56, G57. So if you ever run into an issue where you're fighting the cam system trying to do that, right here is where that usually is caused, by having that set on automatic. Okay, the axis control should be default because we've got the 5-axis post picked. And the rotary axis, this is going to be no rotation. Okay, we're going to do everything we do is going to be positional through the planes. Nothing we're going to do is going to be actually through the rotary axis control. Okay, so this will be no rotation each time. Yes. Well, they've got G54 through 59. Then it's got like G51.1, G50. It's got all the auxiliary offsets too. Yeah. So, okay, I'm gonna go ahead and check mark, and you can see that spot face right there. Okay. While we're here, I'm gonna go ahead and fit this to my screen. And I'm going to save this view sheet down here. So I'm going to go down here and I'm going to save view sheet bookmark. I'm going to rename this my 5-axis origin. In the view sheets, if you right click and you go to the settings, you can see here, this is in your config too, you can see everything that's going to save with the view sheet. So that means each time you click on this tab down there, after we switch the view sheets here in a second, it's going to automatically reload whatever WCS, construction plane, and tool plane you want, which are the main reasons I use view sheets. It makes it a lot quicker than having to go back to your planes manager and switch planes around when you want to do different operations. All the other stuff's just kind of the other bells and whistles that come with it. All right. The next thing we're going to do is we're going to set up a plane to do the holes. Those are at a 55-degree angle on this part. If I had a print, I could show you that, but these are at a 55-degree angle coming through in those 4 places. So I'm just going to rotate the part kind of straight up like this. Okay, and what I'm going to do is I'm going to go to my planes. I want to do a plane to points up to this circle right here. Okay, and if you think about it, I could do this. I could create geometry to create this plane pretty easily and then move the origin back. But what I could do is just think about what my rotation values need to be. If I know it's 55 degrees up, let's just make another copy of the 5-axis WCS here. So I'm going to copy this, duplicate, sorry. And then I'm going to name this one my 55-degree plane. I'm going to hit the equal sign to make that my active plane. And then what I'm going to do is I'm going to rotate everything to where I can line it up with that plane. So I'm going to go to my top view first. So I just hit Alt-1. I'm looking at it straight over the top. What I want to do is I want to take and rotate this to where basically my y-axis is pointing at this hole. So how many degrees would that be? Be 45, right? We're straight up at 90. Here's 180. We're basically wanting to go 45 degrees over around the z-axis here. So I'm just going to right click on this plane and hit edit. And looking at it from the top here, I'm going to click on the blue arc and I'm just going to rotate it around 45 degrees. Or I could just grab the blue arc, click on it and type in 45 and hit enter. And that will rotate it around. So now we're looking at it like this. Okay. All right. The next thing I want is my z-axis, right? I want the z pointing straight up at that. So now, if I know it's 55 degrees, and I want the z pointing straight up at it, that means I want to tip the y down, right? So I'm going to grab a hold of the one that's rotating around the x right here. So I clicked on the red arc, and I'm just going to rotate that down 55 degrees. Okay, so I just clicked on the middle of the red arc there, and I brought it down 55 degrees. Okay, there is where it started. Started rotating it. It's going negative, so I can just type in negative 55 and hit enter and place that one. And now this plane is set to that origin. So now if I go to my isometric view, with this being my active plane completely, that hole's facing straight up. Everybody get it okay? With the print sitting in front of you, that would make more sense. Okay. Now, I could have also, set that using geometry. Or I guess not geometry, but yeah, I would have had to create some geometry, I guess. We will, yeah. Hold on just one sec. So I could have done that by creating some wireframe on there. I could have created a circle on that edge. Could have created some lines on that circle. Like so, and deleted those, and created it like this. And then I could have went in and say I'm going to create by geometry and use those two lines and done it like that, and then moved it back to the 0, 0, 0 to get that plane oriented correctly. Okay, so that's another way. If it had a solid face like the other counterbore side was, I could have picked the solid face, but since it's a hole, I can't really use the solid for it. Okay, I don't need these because we've already got it. All right, so go to isometric, make sure that's pointing up, and just kind of fit it back to your screen. Everybody got it? And then, okay, change the WCS over here. Click on the 5-axis WCS right here. So my 55-degree plane is my construction and my tool plane. My WCS I moved to the 5-axis plane because that's what I'm going to want in the tool paths that I'm working with to do these holes. And then I'm going to go down and tell it add view sheet right here. Hit the little plus mark. And this one I'm going to call my 55-degree origin. Once you've added it and named it, right click on it and save the view sheet bookmark. Because what that will do is not only will it switch the planes, but it also will bring it back to this orientation. Okay, so when I click on this bookmark, it takes me back to top, or 5-axis WCS across the board. Then when I click this one, it's going to take me to this orientation and here, but if I hit top view right now, it wants to go to the top view for whatever WCS is active. So the bookmark, okay, that's what's going to orient the part the way I kind of want to be looking at it. Does that make sense to everybody? The graphics view, anytime you hit Alt-1 right now, it's going to follow the WCS setting. So a bookmark kind of overrides that and orients it the way you want it. Okay. All right, let's go to toolpaths. I'm just going to take this toolpath we have right here, and I'm going to copy it and paste it after itself. And we're going to do a little bit of modifying, obviously. So first off, let's go into the parameters of it. And whenever we're working with multi-axis, usually the first place when you copy and paste a toolpath that you want to go is your planes, because you want everything pulling from the correct orientation. So I'm going to go in here and I'm going to go to my tool plane and I'm going to change that to my 55 degree. And then I'm going to carry that over to the construction plane. WCS working coordinate system is always going to be that 5-axis WCS. We're good? Guys all right back there? Okay. All right, once we've switched the planes, now we can start back up at the top because we've got to go pick the geometry for that hole. So let's unselect that top spot faces geometry, and then let's go chain this edge right here. Okay, we're going to chain this edge right here inside of that bore. Which view am I in? I'm in the bookmark view. The 5x 55 degree origin bookmark. Pick that edge. I make sure it's going counterclockwise once again. And then I can check mark. Most of the other settings you probably wouldn't change much because you're basically going to do the same thing, just we're going quite a bit deeper. So we come in and we're going to tell it maybe the comment here. Ramp bore, 55 degree holes. Cut parameters and most other stuff in here I probably wouldn't mess with much. Let me go see what size the diameter of this arc is. I know they're quite a bit smaller. They're 650, so we should be okay with that 10%. We'll see here in a second. We're not using cutter comp right now, so it shouldn't matter anyhow. But linking parameters, top of stock. Well, I would click on that, and basically I would pick this top edge right here, which it says it's 1.367" is what it pulled in there. But I got to think about the fact that this thing's a full round right now, so there's a little bit more there than what it says. So what I would probably do here is make that like 1.5 inches. In the actual file, what I did was I went to each plane with the sphere on the screen, and then I actually did a bounding box, so I knew exactly where the very top of the sphere was at each location, which it brought in some oddball number, but that way you weren't cutting any air at all. For the depth here, I'm going to pick the depth down in the part somewhere. I got to figure out how deep do I need to go to where these all meet in the middle, basically. Okay. For now, I'm just going to go down in here and pick this spot down in the part quite a bit, which brought in 152 thousandths. So I'd have to be thinking about my end mill and what it actually could do. If I'm using a 1/2 inch end mill, they've got 1 inch and a quarter is all the flute they've got, so that probably would be the max I'd be able to do. So maybe 0.25. Same thing there. If I was machining this part like I was and making hundreds and hundreds and hundreds of these, I'm going to do the math and figure out exactly how deep do I really need to go to make sure these all intersect whenever I bore them out. Okay. Today, we're not going to worry about going into the trouble of trying to figure that all out. Alright, so we check our planes. They should still be good, and as long as they read right, we should be able to check out and regenerate this. And there you see it boring down through there. And obviously, if I rotate it around a little bit, you can see I'm starting plenty above the top of that part, and I'm probably going more than enough down into the part for now, but we're not going to worry about that too much. Okay. Now, we're going to go ahead and transform and do the other 3 locations. Okay. So with that toolpath selected, did everybody get that one okay? Make sure everybody's good. We got it? Alright. We're going to go, and with that one selected, go to toolpath transform. We're going to switch to rotate, and we're going to rotate the tool plane. I'm going to include the origin. I do not want to include the WCS. I don't want it spinning the WCS. It's going to stay where it's at.
Where's the toolpath train?
Over here in utilities in the toolpath. Right here. So make sure you got that toolpath picked and hit toolpath transform. We're going to do a rotate. We're going to switch to a tool plane, but like I said, we don't want to include the WCS because we want it staying set and we're spinning our orientation around it. Source type, NCIs, typically what I leave. The group doesn't matter because we only have one toolpath selected. If we were taking multiple toolpaths, say we spot drilled and tapped these, we wanted to do all the spot drilling first, then all the drilling and all the tapping, that would matter. You can either have it do everything at one spot and then do it, or do each different operation individually as it rotates around. Over here, work offset numbering. This is what you want to make sure is set to maintain sources operations, and that's the same reason we took the automatic off of the toolpath. Okay, because I've had it where I set this to maintain, but I left the toolpath on automatic, and it still tried to automatically increment the work offsets. We're going to go to rotate. Okay. Rotation plane. Well, let's think about what plane we want that to rotate around. Basically, we're rotating. You know, when we've done this in the past, we've rotated on some parts on the 4th axis, and we rotate around the right side to rotate around the part like this. Okay, we're wanting to rotate the part around the original top or the original 5-axis WCS. So that's what I would normally set that to on this. Okay, I would set it to that 5-axis WCS that I used. Not sure why it didn't grab it. I guess because it's the same as top, maybe. So it's the same thing as the top plane. It just didn't show in the name there. It's weird. So we're going to have 90 degrees between the first one and the second one, and then 90 degrees between the next two. We're doing 3 more total. So if you check mark out, you see it crossing in the middle there. If I watch this on verify now, there's my sphere. Go a little bit slower, it'd be nice. Okay. All right. La da da da. It's taking a nice long time to give us this in graphics here, but all right. So I could probably speed up my ramp to make that happen a little faster, but it's playing through this a little quicker. And there it comes rotating in for the second hole. Even had it in turbo mode and it wasn't going very quick. Okay, now that we've got that, we're ready to do the 4 holes around the sides. So, same thing, I'd go to my planes. I'd make myself a duplicate of the 5-axis WCS. And I'd call this my side hole plane. Whatever you recognize what it is, you know, you just whatever you would want to title it. I'm going to hit the equal sign to make that my active plane right now. And then I got to think about which way do I want my tool coming in here. So this only takes 1 rotation. My X and Y are good. I just need to get my Z rotated where I need it. I'm going to hide these tool paths so we don't have to see those. Okay. So I want to get my Z where I need it, so I'm going to right click and edit. And I'm going to rotate it basically straight up around the X-axis. Yep. We're gonna rotate it around. We're gonna rotate it around that X-axis, straight up 90 degrees. So it looks like -90 is what it's gonna take. Once I've rotated around, I got my Z pointing straight up at this hole over here, okay, which is what I'm after. It's pointing straight up. I can make that my active plane. You want to rotate around the red so the Z is pointing straight up, or straight towards the hole. So once I've got that plane set, I made it my active plane for right now. So I hit Alt 7 and it's isometric, and I can fit this to my screen and get it kind of where I need it. Then, same thing, I'm going to change my WCS. Okay, I'm going to change my WCS to the 5-axis original one. And I'm going to create my new view sheet. I'm going to call this one my side hole origin. I'm going to right click and save view sheet bookmark. I don't know. I think if you change this and you want to go back to it, you do have to double click on it. So like if it's already on that view sheet but you switched up the views, to get it to go back you got to double click on it. Okay. Everybody ready? This time, instead of copying the toolpath, I'm just going to select it. So I'm going to go to my contour. I'm going to pick this edge right here. Okay, I don't want to pick the outside of the chamfer because then it's going to try to bore a hole this big. So I'm going to pick this edge right here. I'm going to make sure it's going counterclockwise. And I'll check mark. For the tool, I'll pick that 1/2" end mill and give it a comment. Ramp bore side holes. For the cut parameters this time, I'm going to change my ramp depth to 200 thousandths, which would kill the end mill, but for the fact that it was verifying so slowly, I'm going to let it ramp a little more aggressively for the sake of the computer. Yes. Well, that's because you guys didn't change the WCS. So, everybody else good? So what they did was they picked the wrong hole that wasn't planar. Okay, they picked a hole that was not planar with the orientation that we're in, and it pretty much locks it up to contour type 3D. So if I accidentally, I'll just do it real quick. If I'm not making sure that I'm in the right orientation, okay, and I go grab this hole, which is 90 degrees opposite of the orientation I'm in, looks good there, but when I get here, well, I guess it's not going to do it for me. Cutter compensation not successful. Alright, there we go. See how it's gone now? It's because I was still in the toolpath. I don't have the ramp option, and that's because I've picked a chain that is not planar with this orientation we're in. Okay, if I go back to the view sheet here and I look at it, I picked this chain that's rotating like this, and I needed to pick this one. So that's what happened to both of those guys. So if you see something like that, anytime it locks it out and doesn't give you the option you want, sometimes it's because you might have picked the wrong geometry. Okay, so same thing, like I said, I'm going to do a ramp. Mine's gone again. One sec. Guess you got to exit out and come back in to get it to turn back on. I'm going to do a ramp. I'm going to go 200 thou just to get it to verify a little quicker. This time in the linking parameters, since I'm 90 degrees up on this sphere, and I know the sphere was in 1 inch 15/16, the top of stock I can type in 1 inch 0.9375 and divide that by 2, and I know exactly what my top of stock is. And then for the depth, I'm just going to go a little bit past 0, the center line. So I'm going to go to minus, I don't know, 25 thou. Okay, because the center line of the part now, with it rotated over 90 degrees, 0's right in the center of the part. My plane should have automatically, since we set that view sheet up the way we did, and then we created a new toolpath, the plane should have automatically came in. That's why I went back and did it this way this time. When you copy and paste toolpaths, it kind of takes the advantage of the view sheets away from you, because you still have to come in here and change them. So we should be able to check mark out now and let that generate this toolpath, and you should see a spiral ramping down in there for that one. And then what I would do is I'd select that toolpath. I'd do another transform toolpath exactly like the last one. I wouldn't change anything in here at all. Everything should already be good to go. We're still rotating around the original top plane to do the other 3 bores. Now, the reason I would want to split those 2 transforms up, I wouldn't want to do both my ramps and then do one transform and select both toolpaths, because what it would do is it would try to do one angled hole, and then it'd want to rotate over and do one side hole, and then it'd want to rotate over and back up and do an angled hole, and you'd have the trunnion sitting there wanting to go back and forth. So here it's just going to literally just be rotating the rotary on the trunnion with it already positioned at the right angle. Does that make sense? A little bit? It's just ways to streamline the toolpaths and how much repositioning goes on. Alright, so if we watch that now, hopefully this time it'll verify a little quicker since I bumped up that ramp depth pretty considerably. Oh yeah, hammer down now. There's those 4 holes going in. And here comes our 90-degree holes. There we go. Did everybody get all those? Okay. We're good? Okay, so you got them all right? All right. So here's why the view sheets are nice, because now I've got all my boring done with my 1/2-inch end mill. I want to go and put my chamfers at the tops of all the holes. So now I can go back to my original view sheet. Or actually, since the trunnion's already rotated over, let's stay here on the side. We'll chamfer the side holes. We'll come back up to the 55-degree holes, then we'll do the top hole. Okay, that way the trunnion doesn't have to come here to go back to here. I'm going to come down and pick a contour toolpath. Now there is, and you guys stay right here where you're at, but there is this this model chamfer toolpath that's in here. I'm not a big fan of it. maybe because I'm old school and I've gotten so used to just using the contour toolpath. The only difference between doing the contour is the model chamfer. Literally, you pick the chamfer that's there on if it's on your model, and you don't have to set the size or anything. It just kind of automatically defaults to it. It grabs a hold of it. But we're going to use the contour. I'm going to pick this edge. Once again, I'm picking the edge on the inside of the chamfer, just like you would if it was wireframe. I'm going to check mark there. For the tool, I'm going to use the 90-degree drill mill that's in here. Chamfer side holes. The cut parameters, should be able to change that to 2D chamfer. Chamfer width, okay, will be whatever the width of your chamfer is. So in this case, you know, we can make it 80 thou. The only thing you gotta be aware of is whatever that width is, you might have to adjust your tip offset here accordingly. So I'm gonna make my tip offset 50 thou. If I had 100 thou with an 80 thou chamfer on a 3/8 tool, that's only like 7 thou before the straight edge up at the top. This will give us a little more room there. Linking parameters, I would set my top of stock to the top of the part here, and I would set the chamfer depth to the top of the part here. Okay. Which both of them came in at 0.885807. You will see when you get into multi-axis stuff, a lot of times you're going to see some real oddball coordinates. Okay, that they're not going to be like if the part's this, when you start rotating it around and doing different orientations and stuff, things angularly, there it is, they're going to measure a little bit different, right? You got your hypotenuses going on. So we'll go ahead and check our planes. They should be good thanks to the fact we used our view sheet. And we should be able to check mark out, and you should see a chamfer type toolpath. If I just watch these two toolpaths alone just so I can see the chamfer. There we go. Okay. We would take that. What do you think we would do with it next? Transform it around. All right. It's a repeating feature. I can just do that again without changing anything in the transform. It's all set and ready. Same rotation, same numbers and everything. I'll bring that in. Okay. Everybody got the side chamfer and the transform okay? All right. You guys good? All right. Let's look here. It's kind of a weird size chamfer, isn't it? guess it's right at 100 thou for the width. All right, so let's go up to the 55-degree view sheet. Let's check your planes. It should have just set the 55-degree for your construction and tool, and the WCS back at 5-axis still. And this time, just for fun, let's go down and let's use that model chamfer toolpath. Machine safe horizontal chamfers on solid models.
Is everything the same as mine?
I went to your go to your 55-degree view sheet. Okay, which should set your 55-degree plane construction tool and your WCS as 5-axis WCS. Pick model chamfer. Anybody else has popped this up? Just tell it okay. It should be okay. Find out. It still brought the toolpath in. I'm not sure why it did that. All right. For the chain geometry, we're going to pick that. It should default to solids. And I'm going to zoom in and I'm going to pick this solid face right here. And I'm going to check mark. We're going to go to the, so here's something just to show you something here. See the avoidance option here? If you're chamfering something along a wall that comes into a flat wall like this, you can do it just kind of like a 3D toolpath. You can set those walls as avoidance, and it will automatically shorten the chamfer however much it needs to based on your tool geometry and how much clearance you tell it to have. So if you've got areas that you want to get in there and chamfer, but you're not sure how far you can go without hitting the wall, you can use this to do that. Tool, same tool. All right, we're going to chamfer 55-degree holes. Set our chamfer width and our tip offset. Another thing I don't particularly like about this is you kind of have to choose on your lead in, lead out. I can't do my 10 and 10. So I either have to do an arc entry, but if I go to perpendicular, watch what happens here. My radius goes away. So it's either straight in or ramp, ramp. I'm not sure why. For your linking parameters, see how there's nothing there anymore? Okay, it's all driving off the model. So your feed plane is obviously how far up above you want to start it. So I can start like 50 thou above and set my clearance to 1/4 inch and my retract to 1/4 inch, my clearance to 1 inch, but they're all going incremental from where we selected the model. So wherever the top part of that chamfer is, everything's going incremental from there. Plane should be 5-axis, 55-degree plane. Should be able to check mark out. Uh-oh. Only chamfer mill tools are supported. I did not know that. Well, there's another bummer about this toolpath. I didn't know you could only use chamfer mills. Alright. Screw this toolpath. I'm out. Apparently, the model chamfer only allows you to use tools that have been set up as chamfer mills, and since we have it set up as a spot drill, it doesn't like it. So, I'm going to go back to contour. I'm going to select this hole here. Make sure it's going counterclockwise. And then just set it up just like we did before, since we don't have this set up as a chamfer mill. So everything should have pretty much defaulted in, since the last thing we did was that last chamfer. All the cut parameters and lead in, lead out. The only thing we had to change is our top of stock. Top of stock would be this edge right here, top of the chamfer, and the depth would be set the same. And that should generate a standard chamfer toolpath for that edge. I wonder why that chamfer model doesn't support spot drills or 90-degree tools like this. Toolpath transform to chamfer the others. Okay. Does everybody have everything up till there? Does it make sense? Okay. All right. This is by far, I mean, almost everything I do on the 5-axis, unless I'm having a tour come through or I'm doing some kind of weird part that I'm trying to port inside of something, but pretty much everything I do on the 5-axis is positional. Okay, meaning that I'm setting up planes and I'm using my 2D toolpaths or my 3D toolpaths. Okay, I've got some parts that I've made in the past where, you know, I come in, I position it over 90 degrees, and I 3D toolpath whatever the features are, then I rotate it 180 and 3D the other side, flip it up on the top and 3D the top of it, and once it's all done, it all blends together. But I'm not trying to go through the trouble of getting all the clearance angles and stuff set to use a multi-surface toolpath to do it all at once. Okay, it doesn't save me any time. Typically it takes longer because you end up fighting a lot of collision situations, and it's a lot easier just to position the machine and then let it just work there, just like a 3-axis mill. All right. So if I was still running this part, the next thing I obviously would do would be chamfer this top bore. Okay, once I'd get the chamfer there, then I'd come in and I'd turn on my logo and I'd engrave my logo, and this part would be done. And we don't really need to do that part. Any questions? Okay. Just remember, your WCS is always going to be whatever your original working coordinate system is, because that's what you're going to set up the machine. That's what it's going to look to, and that's how the cam system tells it to rotate and index based on that. Okay. The others are going to be whatever plane you're in. And I recommend on the 5-axis, even for this, view sheets, because while I switch view sheets, it makes sure that WCS gets changed. Okay, it'll change the view, but the WCS stays where it's at. All right. It wasn't bad. Maybe an hour and 10 minutes. Call that a win.